Lesson 3-4, finding an equation of a line. The big idea is postulates and theorems of geometry about lines tell when exactly one line is determined from given information. And the equation of that line can be determined algebraically. Point-slope theorem, or what we know as point-slope form. If a line contains the point x1, y1, so just some coordinate, and has the slope m, then it has an equation y minus y1 equals m times the quantity x minus x1. This is a linear equation, you should remember. This was called point-slope form in algebra. Remember, this y and this x will not contain any numbers in it. The only things that have numbers is my x1, y1 is my coordinate point, x1, y1, okay? And slope will have a value. The rest of them you just leave as y and x. Example 1 says, in a physics experiment, a spring is 11 centimeters long and a 13-gram weight attached, with the 13-gram weight attached. Its length increases 0.5 centimeters with each additional gram of weight. This is a constant increase situation up to the spring's elastic limit. Write a formula relating spring length L and weight W. Then graph the situation. Then graph the equation. Okay, I'm going to do this a little bit differently than what your book does, so you might want to pay attention here. The first thing is I'm going to go find slope right away. And slope is normally a rate of change. So if you look here, it says length increases 0.5 centimeters with an additional gram of weight. Okay? So what that's telling us is that length increases for each additional gram of weight, which means I'm going to have length divided by weight, which means for my slope, this is my rise, this is my run, which means length is the change in y's, over the change in x's. So my change in length goes up 0.5 centimeters. My weight gets changed by just 1 gram of weight. So 0.5 divided by 1 is just simply 0.5, which this is then my slope. Now, what you have to find out here, length is my y value, weight is my x value. So they gave us some information here. Length is my y value, weight is my x value. That's very important here because they give you actually length first, weight second. So you got to watch yourself because since they gave us length, 11 goes here, 13 goes here. So I have a point, I have my slope, I can put it in the point-slope form. So y minus y1 is 11 equals my slope, which is 0.5, times the quantity x minus x sub 1, which x sub 1, is 13. So there's my equation. Can we graph this? Sure, you could graph this. And my graph's probably not going to be real pretty, but I can graph 13, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Went clear out there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 13, 11 is plotted right here. And then my slope says I go up a half over 1. So up a half over 1 is going to take me right here. Sorry. Oh, that's too far for a half, ain't it? Probably about right here. And so I get an equation that looks something like this, or a line that looks something like this. Okay? Now, could I put this in the slope-intercept form? Sure, you could put this in the slope-intercept form. Y minus 11 is equal to 0.5 times x. What's half of 13? You all are going to say a positive times a negative is negative 6.5. Okay? And then what I could have done was add 11 now. Add 11. And when I add 11, I get y equals 0.5x. Okay? And if I add 11 to 6.5, leaves me with 4.5. Okay? So what I essentially, and like I said, that's probably a pretty bad graph, but what I could have done was go up 1, 2, 3, 4, 5, 4.5, and I could have went up 1 over 1, and it would have looked something like this. So this looks like a better one than that. Also, you can graph it on your calculator. Disregard this. Okay, bad picture. Example 2, find an equation of a line P through 4, 7 and 6, negative 2. Now don't get all worked up here. We're looking for slope, we're looking for a point. Well, they gave us 2 points. Well, if you give me 2 points, I can easily find slope, correct? If you remember, slope is y2 minus y1 all over x2 minus x1. So, can we find slope of these 2 lines? Sure. Negative 2 minus 7 all over 6 minus 4. Negative 2 minus 7 is a negative 9. 6 minus 4 is 2. Okay? So here's my slope. M equals a negative 9/2. Do I have a point? Well, I could use this point right here, 4, 7. You could also use this point. I'm going to use this one because they're both positive numbers. So, y minus y1. What's y1? 7. Equals the slope, which is a negative 9/2, times the quantity x minus x1, which is 4. And that is my equation for a line that goes through 4, 7 and 6, negative 2. Very important to know. Because this graph does not have a constant rate of change over its domain, t that goes from 0 to 210, it cannot be represented by a single linear equation. But you can write an equation for each segment of the graph that does not have a constant rate of change. Because the graph is described in pieces, the graph and the function are called piecewise linear. The graph is a union of several segments. Each segment can be described by a linear function that has a restricted domain indicating where the segment starts and it stops. So if you notice, this line segment is increasing from here to here. So you could find slope of this line, okay? And its duration is from 0 all the way to 45 minutes. If you notice from 45 minutes to 60 minutes, you stayed at the same distance away, okay? Same thing here. From 60 to 90, it's climbing up again. From 90 to 120, it stayed still, so on and so forth. Okay. Example 3 says, write a piecewise linear function for the first 2 segments of Frank's bicycle trip as described in the graph above. Estimate the values of the segment endpoints where necessary. So, here's my piecewise deal. Y equals, and then we're going to look at the first 2 segments. from 0 to 45 minutes and from 45 to 60. Okay, so we're going to use this equation when it goes from 0 to 45 minutes and use this from 45 to 60. Well, this equation right here should be fairly easy. We stayed at 6, correct? So y equals 6 when x equals, and I should have wrote that better, when x equals 45 to 60. Okay? Now, we got to find a linear equation for this next one. Okay? When x equals 0 to 45. So, we got to get a point. Okay? Actually, we need 2 points. Well, 0, 0 to 45, comma 6, right? 0, 0 and 45, comma 6. y2 minus y1 gives me 6. 45 minus 0 gives me 45. 6 divided by 45, we know 3 goes into both those. 3 goes into 6 twice. 3 goes into 45 15 times. So 2/15 is my slope. Okay. I can use this as my x1, y1. So y minus y1, which is 0, equals my slope, which is 2/15, times x minus 0. But what's going to happen to my zeros? Y minus 0 is just y. 2/15 times x is just 2/15 x. So that's what my linear equation looks like. So up top here, y equals 2/15 x is going to be my equation for that span from 0 all the way to 45. Okay? Quiz Yourself 3 says, how far from home was Frank after 55 minutes? Well, where's 55 minutes at? 55 minutes is right here. He was approximately 6 miles from home. Now, why do you think he plateaus here? Why do you think there's these plateaus? Okay. Why there might be some plateaus in this function is he might have took a rest here after 6 miles. Might have rested here, stopped at a shop, got a donut, something like that. Here he might have been at somebody else's house, stayed there, worked there, yada yada yada, did homework there, and then left to go back home again. That's all I have for you today. Please enjoy. We'll see you tomorrow.